I'm going to talk about digital twins for the next 20 minutes. And normally when I talk about a digital twin, the question is, okay, how do you define it? There are many ways to define a digital twin. A digital twin, for me, and I think most of you would agree, is a virtual representation of a real thing, a virtual representation of a real asset. However, it is a bit more than just a visual representation. A digital twin has to express all of the semantics of the asset. By that I mean, if you're talking about this chair, the digital twin should be able to say what color it is. Of course, you can see that. It should also be able to say what material is it, what's its weight. So all of the information that goes behind making of that particular asset needs to be expressed or needs to be made expressive. Secondly, it also needs to convey all of the dynamics of that particular asset, which means it's not just a static database of information, but it's also responding and presenting information on how that particular asset is operating. So a digital twin, in summary, is a virtual representation of a physical asset, but is expressive of its semantics and is also communicating its dynamics. That's really what it is. Now, we've seen digital twins taking the manufacturing world quite by storm. A combination of digital twins and IoT has transformed how machines are produced. For example, a turbine. So when a product is designed, it's designed for manufacturing. We heard this always. A product when it's manufactured gets onto the field. IoT is able to help get data back about the actual performance that feeds back into design improvements, feeds back into manufacturing improvements, resulting in better operations. So this feedback loop, which a digital twin affords, is very powerful. Now, that's not entirely true for the built environment. We don't build the exact same copy of the building again. We build everything very uniquely. So there's a bit of a difference between how a digital twin potentially gets designed, built, and used in a manufacturing industry and how it potentially gets applied into the built environment. The other question which is normally asked is, isn't a BIM model a digital twin? It certainly is a seed for a digital twin, but it's not the digital twin itself. Because if you go back to the conversation we had a minute ago in regard to the definition of what a digital twin is, the BIM definitely represents what that asset is, the virtual representation of it. So it provides that base layer, and then it builds on further with a lot more information that's produced during construction, during commissioning, during operations, and makes that physical asset a lot more expressive and provides a lot more insight to the user. There is a digital twin which we all know and use day to day. So let's talk a little bit about that, right? I'm talking about maps. Now, this is a digital twin in our day-to-day lives that probably we can't do without nowadays, right? So it starts with, when we talk about maps and you go back in time, you recognize the world that we were in. It was very, very different. Not only was it different for us in terms of how we did our day-to-day things, but there were businesses which existed, which don't exist anymore. So the maps has transformed our lives, it has transformed businesses, it has changed the way people do things. But if you go back in time and look at what was maps in 2004, when it was 4 or 5, when Google introduced maps, that was it. It was 2D, it was a static image, it was North America, okay, and very little information. And we are a little bit ahead of that right now. We are not, I wouldn't say we are at that point, but we are not at where Maps is today. So where is it today? Now that's the map of South Dublin. So you can see that it's very expressive in terms of what it provides as information there as a static image. It has topographical information, so it has all of your elevations and all of the data that you need, satellite data. And now it gets interesting. It has traffic data. So which means it's starting to make it more dynamic. It's bringing the information about not just the average traffic data, but even the live data. So it's getting more data back onto the same platform. And then it adds business information. And adding business information to it allows businesses to create a new business model about how they interact and engage with their clients. So businesses are able to communicate and engage with their stakeholders. We plan our travel. I mean, would I take my car? Would I take a public transport? Would I take the DART, or would I take a taxi? Would I use a public taxi, or take an Uber? I have all the data that I need to make my decisions on that day. So it's become a lot more expressive. Even giving me information about what would it normally take me on a Monday at 8 o'clock in the morning, how much time should I plan for? So it's extremely powerful. And further, you can get into street views, you can get into inside the building views. If you think about it, all of that we just saw is convergence. It's convergence of information onto a platform. The interesting thing here is you bring data into a platform and allow applications to build on it. Those applications create new data, which allows more applications to be built on it. It's very interesting when you think about it. It's a kind of a self-perpetuating cycle, a positive cycle, which enables newer and newer things, which is why innovation happens in that exponential and progressive way, because as we do things, we discover new opportunities. And those new opportunities result in new data, resulting in further opportunities. It's amazing. Now, we are going to see something like that happening in the built environment too. It's definitely happening, beginning to happen today. A lot of the stuff that we saw this morning from the speakers is very interesting, because all of that, it's not just a futuristic vision which Martin presented. It's very much a reality that we are all going to experience in the very near future. And the important thing is, we don't have to wait for a headset to be reality. And the important thing is, you need to start preparing the data today in order to leverage that experience. Because if the data is not there, we're not going to get that experience. And the point, therefore, is we got to start now. So when you look at buildings, what are we talking about in terms of information layers? So let's start with the physical asset, right? That's the physical asset. The physical asset is represented by a BIM model. There's a virtual asset. The virtual asset then obviously gets expressive in terms of what it has inside. It is the systems inside it. You want to identify what is of interest to you. That's a chiller. You can find that chiller. There is a representation of the chiller, the physical information about that, the photographic information about that, all of the data about that chiller. Now, this data is going to be developing from over time. So if a building is in a design stage, there is so much of design information that needs to be captured to making up this digital twin. So you start with the design data, you add on all of the construction data, all the construction and the commissioning data. A lot of the information gets produced downstream. So we don't fully recognize sometimes that when a designer produces a building design, he doesn't know what manufacturer and what model number and what performance characteristics that particular piece of equipment will have. There's a performance requirement stated, but the decision on the piece of equipment and the data about it gets made much down the line, and even down to the point of collecting data during commissioning. So there needs to be a system by which we capture all of that data, unrestricted by the data structure of a design tool. Now, design tools are not designed to be flexible in terms of its data structures. Now, when you start creating a digital twin with flexible information, you need to have the capability to define data structures that you need, the workflows that you need, the permission models and the security models that you need, depending on the personas involved on the task. There's quite a bit of detail when it comes to realizing the vision of creating a digital twin. Once it's done, great. You can express it on a futuristic headwear, which can provide you that information on the field. Awesome. But to get to that point is the point I'm trying to convey today. So we have all this data that we need to capture and aggregate through the process. And ultimately, when you have all of that data, the twin starts becoming live. So at the time of commissioning and handover, you've produced a digital representation of that asset. It expresses all of the semantics of all of the assets inside, and it now starts connecting to the operational systems and start representing the dynamics of that built environment. For example, if you have to bring together the asset information about that chiller, if you want to bring the performance information about that chiller, so all of that data starts coming together and gives you this window to that built asset in one integrated manner. So how do we get there? It's all interesting, right? I don't think anyone is going to argue and say, no, that's not useful. I mean, we all can agree that it's very powerful to have one integrated data model that represents all of the information that we want, accessible anywhere, anytime, by whoever has the rights to do that. Now, but how do we get there? Now, it's interesting thing is, we can start with BIM. A digital twin doesn't have to be based on a BIM. It can be based upon a 2D drawing. It can be based on 1D. We can start with producing a list of assets that you care about and start putting data around it, right? Is it rich enough? Probably yes, for some purposes, may not be for other purposes. So we've got to think about where do we really start, and we can slice the cake as based upon what we have as an opportunity at any given point. If we are starting from BIM, there are some very important considerations to make. Now, BIM has traditionally been produced for creating drawings efficiently, right? Coordinating, clash detecting, coordinating, producing drawings. That has to, of course, happen. That's productive, that's valuable. But we've got to go much more than that. We've got to start thinking about data. Every piece of, every single element in that model needs to be descriptive, needs to be expressive as to what it is. So classifications, we got to start with making sure that the models are well classified. Whether it's uniclass, whether it is omniclass or uniformat, doesn't matter, but it has to be done in the context of how it's going to be consumed. Because if the data is not structured, all of our beautiful visions and futuristic views will simply not happen because the systems, the machines, will not understand what's in the model. So starting with classifications, making sure the model data is complete and rich enough, making sure all of the data that we want to capture downstream, including documents. I didn't mention documents in the previous slide. That's an important part of the digital twin as well, making sure that that field engineer who is going there to a particular piece of equipment has access to the correct maintenance guide when he's on the field is super critical. Now, making sure the data is captured, all of the documents come through, and then start building the integrations into the real-time systems that we have, be it your CMMS systems, be it the building automation systems. All of that integration also needs to happen. The good thing is integrations are becoming easy. Even with building automation, there was a time when integrating into a Siemens or a Johnson or a Honeywell or whoever Cylon controls, any BMS system was a challenge. Today, with standards like BACnet, which has always been there, and more importantly, standards like Haystack and Bricks, makes it very easy for us to know what data point does this represent. In the past, a commissioning engineer would put a tag on a particular sensor value, which you would never know what it is. Today, if it is Haystack or Bricks coded, you know exactly that sensor value represents an airflow or the damper position of this particular piece of asset, which means you can integrate that back into your digital twin. So it's getting easier, but we've got to have the infrastructure to make it happen. So Invicara, we are a provider of building information management solutions, and we have a solution approach based upon a platform. The Invicara platform allows us to shape the strategy based upon what is the outcome you're expecting. So we always recommend start with the end in mind. Why are we doing this? How are we going to use this information? What are the specific workflows that's going to be valuable to the client? So we start with saying why, and then who define, and then define the who and how and when and what in terms of how the data is going to be aggregated and managed. Classification, we talked about it. It's very simple. It's about making sure your models are very descriptive. The white box is a A, the pink is a B, and yellow is a C. Doesn't matter who's building the model. If you look at a model, you need to know that that's A and that's B and that's C. If you did not know that, we wouldn't be able to really make use of that. We can, as a human, maybe look at it and understand what it is, but a machine will not be able to understand what it is. So it becomes super critical to do that. And once you have done that, we now know that for A, we need these 4 pieces of data. For B, we need these 40 pieces of data. And for C, we need 20 pieces of data. So we can define that. And once that's defined, we can set up rules, we can verify, we can validate, we can make sure that the data that we need to drive this workflow is completely seamless, and the data is delivered by the respective stakeholder at each point as the project moves forward. Once that's done, we have the core, the seed, to start aggregating all of the information that makes up the digital twin. So we start bringing the documents together, we start bringing all of the extended information about the asset, about the commissioning data, and then integrate with the building automation and the CMMS systems to provide that single window to what we are wanting to achieve. So that, in short, is the storyboard. It's not too difficult to achieve. We are already doing it today for clients. We have a number of programs where clients have seen the future and recognizing that they've got to seize the opportunity today. Simply because every asset that you're creating is adding to your legacy. So if we start with a vision today and start creating this infrastructure, as we move forward, as the data matures, as your project matures, you start benefiting from the value of the integrations and the impact that it can give to your business. So it's best conceived early. We are living in a commercial world. There are people doing jobs and delivering work for a certain contractual obligation. It's very critical to be able to establish that upfront. If you don't establish these things upfront and we expect that something happens magically at the end, it unfortunately doesn't. So we all know that. So starting early is very critical. And that's an important point, being able to digitalize existing buildings. So we are engaged with a number of commercial real estate organizations who say, great, 95% of our portfolio is already built. Now, we can talk about digital twins and new ways of working for our new infrastructure, but what about everything that exists? Now, obviously, it's very important to be able to digitalize the existing built environment and be able to bring it on a common platform. Why? Because you want to create a standardized system of care. Because if you couldn't do that, it becomes this white elephant, this one-off white elephant that's not going to really improve my business outcome. And in short, in terms even for the trade, the design construction community, which enables all this to happen, I think this is an important point. Handover is the last opportunity to make an impression with a client. Absolutely the last opportunity. And the best way to do that is with the digital twin, because that digital twin is going to leave a continuing value in the hands of the client in the operations of the facility. Over the today afternoon and tomorrow, we're going to hear some very interesting speakers. I hope that this conference is benefiting the industry in Ireland and helping us to continue make progress, which we have started in a very good way. The last 2 years that I've been in Dublin, I've been very excited about how much progress the industry is making, and I look forward to continuing to participate in that. Thank you very much.